of scalar products. Now, scalar product is basically A dot B. We read it as A dot B. So you have a vector here, A1, A2, and we have a second vector here, B1, B2. So this is a column vector, and it's just now in 2 dimensions, X and Y. The formula for scalar products is A dot B is equal to magnitude A, magnitude B, cosine theta. This is the basic formula that we're going to use. So there you have your formula. A dot B is equal to magnitude A, magnitude B, cosine theta. But what is the meaning of this now? Now, we can work with the column vectors, or we can work with our base vectors, where we say that this is then I plus J, when we work with those base vectors. And the base vector is then A dot B means II plus JJ plus KK. This is in 3 dimensions. I'll show you just now the meaning of this. So that means now you actually have I, J, and K. There's your column vector. So it works in 2 dimensions, but it's also going to work in 3 dimensions. We're going to do it in the 3 dimensions right from the start. Then you have magnitude A. Now the magnitude is the length of your one vector, your first vector, which is then I squared plus J squared plus K squared. Then we multiply it with the second vector, so it is also I squared plus J squared plus K squared. And then we have to find that angle. We actually want to find the angle between 2 vectors, cosine theta. So this is the meaning of A dot B is equal to magnitude A, magnitude B, cosine theta. Now let's look at an example, and then you will understand it better. Let's say we have the vector, you can follow there in the books as well. Let's say we have that vector 5, negative 2, and the second vector is, so this is P, and this is Q, and this one is 0, 2. So that is our 2 column vectors. This is in 2 dimensions, X, Y, X, Y. Now, what we want to do now is we want to find the angle between these 2 vectors. So this is the vector P, this is the vector Q, and we want to find that theta there, that angle. That is the whole purpose why we're going to do it. So now we say, what is the formula that we use? A dot B is equal to magnitude A, magnitude B, cosine theta. This is the formula, the one formula that you need to know. What does A dot B means? We said now this is II plus JJ. This is now in 2 dimensions. So what is II plus JJ? II plus JJ. So it's going to be 5 times 0 plus negative 2 times 2. II plus JJ. So here you multiply the 2 vectors with each other. Then we have the magnitude of A, which means this is now only, in this case, going to be B, the magnitude of this vector, which is then 5 squared plus negative 2 squared. Make sure that you use your signs correctly. And then here, this one is going to be the magnitude of 0 squared plus 2 squared cosine theta. This is what you want to calculate. So with algebra, we're going to find the values now and also bring this over so that you can get the angle cosine theta. So this is 0 minus 4, so it is negative 4. And this one is now, so you have to calculate the magnitude there. Use your calculator. I have the square root of 29. So to get rid of it here, I divide with that. And that one is then the square root of 4. Okay. And now to get that angle, you will say negative 4 divided by square root of 29 times square root 4, and then remember to find the angle, it's a second function. So you have to press second function cosine to get the angle there. And this angle is then 111.8 degrees. Try it on your calculator and see if you get the same answer. Now, because of that negative, that's why I can immediately see that this is going to be an obtuse angle, because there's a negative there, that negative cosine. So don't throw it away, make sure that you have it. This works exactly the same in 3 dimensions. We're going to use exactly that same formula there. You will see in the textbooks we have very good examples now. And the exercise that I would like you to try now is exercise 7 on page 37. I will also write it down so that you can follow then if you don't have a textbook. So first do it and then you listen further. So the first one says I have the vector 2, 4 and 3, negative 1. So this is still in 2 dimensions. Now, we must find the angle between these 2 vectors. So this is what we want to find, that angle theta there. The vectors will go outside, arms out there. How do I get angles? I have my one formula that I'm going to use. A dot B is equal to magnitude A, magnitude B, cosine theta. There's that one. So what does magnitude means? II plus JJ is equal to the magnitude of I squared plus J squared times the magnitude of I squared plus J squared cosine theta. Finding that angle there. Okay, so what is II? II will now be 2 times 3, which is 6, plus 4 times negative 1, negative 4, over, and the magnitude here is now 2 squared plus 4 squared. So it's the magnitude of 2 squared plus 4 squared times the magnitude of 3 squared plus negative 1 squared is equal to cosine theta. So to find your angle there now, first you have to do these calculations. It's a good idea to always write it down. We have been 2 over the square root of 20 times the square root of 10 is equal to cosine theta. And now you can press second function cosine 2 divided by square root 20 times square root 10, and my answer is 81.9 degrees. Make sure that you get that same answer there. Okay, the next one is number B. This column vector is 5, 2, and the second one, negative 3, 2. I have to find the angle between these 2 vectors. So that is the angle that you want to find, arms out. What is the formula? A dot B is equal to magnitude A, magnitude B, cosine theta. That is your angle then there. So now I have to do that. What is the meaning? II plus JJ is equal to I squared plus J squared times I squared plus J squared cosine theta. And now we're going to do those calculations. 5 times negative 3 is then negative 15 plus 4 over 5 squared plus 2 squared gives me the square root of 29, and negative 3 squared plus 2 is the square root of 13 is equal to cosine theta. And now we can do the calculation. Second function cosine, you divide here, my answer is 124.5 degrees. Again, there's a negative there, that's why I have a negative answer here. It's an obtuse angle that you will get there. Question 2. In a triangle, okay, now they say A is the point 32, B is the point negative 13, and C is the point 17. And they want you now to find the vector AB and the vector AC. We don't have them at this stage. You have A, this is actually OA, OB, OC. So to find AB, and this is now a very important step, we've looked at it the previous lesson as well. It is the last one minus the first one. So it will be OB minus OA. If we make a mistake there, everything is going to be wrong. So be very careful here. So I can write coordinates as column vectors. We said that also in the previous lesson. My coordinates can change to column vectors because it's from that origin. It's a position vector that we have there. So this vector A is then 3, 2. And the vector B is negative 1, 3. And the vector C is 1, 7. 1, 7. So to find AB now, it's OB minus OA. So OB minus OA. So negative 1 minus 3 is negative 2. And 3 minus 2 is 1. So this is the vector AB. There's the vector AB. Now we want to find AC. So AC is going to be OC minus OA. OC minus OA. So 1 minus 3 is then negative 2. And 7 minus 2 is 5. So this is the column vector for AC and the column vector for AB. So if we want to find that angle now there, theta, remember it will be, they say, find the angle between AB and AC. Now that means A is in the middle. AB and AC, arms out. Okay, so we have the two vectors. What is the formula? A dot B is equal to magnitude A, magnitude B, cosine theta. What is the meaning of that? Here's the two vectors now that we are working with. So A dot B is II, so it is negative 2 times negative 2 plus JJ, 1 times 5, is equal to magnitude. Magnitude is the length. It's always Pythagoras. So it's negative 2 squared plus 1 squared. And then I multiply it with this one, negative 2 squared plus 5 squared cosine theta. So we want to find cosine theta. This is the purpose. We want this angle here. So II plus JJ plus KK. And that gives you, then 13. No, it seems to be that here's a mistake. Let's just go back to AB. The vector AB is then OB minus OA. So it is negative 1 minus 3, which will be negative 4. Negative 4, 1 there. So this will then be negative 4. Sorry, that's how we get the 13. So this is also negative 4 squared there. So that gives us the magnitude of 17 times the magnitude of 29. And in your last step, second function cosine, and the angle is 54.2 degrees. 54.2 degrees. Now when we go now to question 3, now we're going to look at 3 dimensions, but it works exactly the same. So the first one here is 12, 1, negative 12. And the second one is 8, 4, 1. So the formula is still going to be A dot B is equal to magnitude A, magnitude B, cosine theta. So all the time that is the formula that we are using here. Now, what is II plus JJ plus KK now? So now it is II, which is 12 times 8, plus 1 times 4, plus negative 12 times 1. Okay, I'm going to bring this down immediately, is equal to cosine theta. So now Pythagoras is going to be all 3. So it is 12 squared plus 1 squared plus negative 12 squared. This is not 0 here. And then the second one, you multiply here, is 8 squared plus 4 squared plus 1 squared. So cosine theta, it's always good to put that step in between so that we don't make mistakes there. So this is then 96 plus 4 minus 12 over the square root of 81 times 17. We already got the square root there. And then second function cosine, and the answer of theta is 54.9 degrees. So it works exactly the same with the 3 dimensions. Right, the next one is now number B. This one says 4, negative 1, 8, negative 8. And the second column vector is 7, 4, negative 4. Okay, so the formula that we're going to use is A dot B is magnitude A, magnitude B, cosine theta. Every time that one formula that we are using. Right, what does A dot B means? II, so 4 times 7, plus JJ, negative 1 times 4, plus KK, negative 8 times negative 4 is equal to, now when we get the magnitude, you work with one column vector, with your one column vector there. So this is going to be 4 squared plus negative 1 squared plus 8 squared times the second vector here, 7 squared plus 4 squared plus negative 4 squared cosine theta. Cosine theta. So eventually cosine theta is equal to, so we do our calculations here. I have 56 over the square root of 81 times the square root of 81. You can change it to 9 if you want to. And then second function cosine, and the value of theta is 46.3 degrees. I hope you are sure of getting these angles, because this is the basic concept. There's a few things coming up, but this is what we really want to do. Right, and the last one that we're going to do there is number 4. It says in triangle PQR, P has the coordinates 5, negative 3, 1, so it's 3 dimensions. Q is negative 2, 1, 5. And R is equal to 9, 5, 0. So again, we can change from coordinates to column vectors, and you can change from column vectors to coordinates. That's also a question that they ask you sometimes. So this one as a column vector is -2, 1, 5, and this one as a column vector is 9, 5, 0. 9, 5, 0. I can also change it to base vectors. So this is 5i minus 3j plus k. And this is -2i plus j plus 5k. And this one is 9i plus 5j. There is no k. K is 0, so I can omit it. I don't need to write that down. And we want to find the angles of the triangle here. So we're going to use the same method now to find the angles. So you need to find the column vector PQ, and we'll have to find QR, and we'll have to find PR. Now remember, your angle is always there in the middle. So if I want to find Q, PQR, then I will have QP and QR. Can you see? And if we complete the triangle now, if I want R, then it will be RQ and RP. And if I want P, it will be PQ and PR. This is how I will calculate those angles there. We can also call it alpha, beta, and theta, but you will have to have two angles there, and the arms are out, so it's always good to draw the picture. Now, if we do these calculations, we find that P is equal to 90 degrees. Q or R, you can calculate any of them, is 45 degrees, and then obviously the third one is also going to be 45 degrees. So we will calculate them with exactly that same method that we have there. I would like you now to look in your books on page 39. We're looking a little bit at the laws of the scalar product. So what we say is A dot B is the same as B dot A. This is the commutative law that we've learned already. And then A, and then dot B plus C, this is the distributive law. So this is A dot B plus A dot C. So you can also do it like that. What's very important now is the following one. If A dot B is equal to 0, then our vectors are going to be perpendicular. So this is a very important thing that we're going to use here. Okay, so the next exercise that we're looking at now is exercise 9 on page 39. Page 39. Exercise 9. I'll write them down, so if you don't have the book, then you can also follow. So the first one is A is the column vector 3, 2. B is the column vector 5, 3. And C is the column vector -2, 3. Again, first do the exercises and then you mark them. So the question is now calculate the magnitude. Magnitude means, they can also ask it like this, the magnitude of A, the magnitude of B, the magnitude of C. That is what we do. And this is Pythagoras. So it will then be 3 squared plus 2 squared, which is equal to the square root of 13. You can get the value there, or you can give the answer like that. Now, B will then be 5 squared plus 3 squared. And that is the square root of 34. And C is then the square root of, make sure here with your signs, -2 squared plus 3 squared, and that is giving you also the square root of 13. As I say, you can get an answer round it off to 3 significant figures, or we can give it like this. At number B, they ask now, calculate the scalar products of A dot B, B dot C, and C dot A. So we have to get the scalar product of each one then there. So what would be the scalar product of A dot B? II plus JJ, isn't it? So this is 15 plus 6, which is 21. And B dot C, it is negative 10 plus 9, which is negative 1. And then A dot C is then negative 6, positive 6, which is 0. So A dot B, the scalar product, just getting those scalar products there. Then they ask you, which of the pairs of vectors are mutually perpendicular? And it will be this one. If A dot B is 0, then they are perpendicular. That's a very important fact there. And then they say, find a vector which is perpendicular to B. Now, when will I get from 5, 3, let's just write it down here, B is equal to 5, 3. When will this vector be, or which vector will be, will make sure that this will give you a perpendicular one? To get a perpendicular one, it means that this vector that we're going to give us here, II plus JJ, must give us 0. Because if A dot B is 0, then they are perpendicular. So when will I get that? Negative 3, positive 5. Because then you have negative 15 plus 15, and that will give you the 0. There's more than one possibility, because this can also be positive 3 and this one can be negative 5, but that will give you that answer there. Right, the next one is question 2. A is the vector 2, 2, 1, so it's a 3-dimensional one. B is 1, 0, negative 2. And C is 4, negative 5, 2. So there's my column vectors in there. And now they say calculate the column, the scalar product of A dot B, B dot C, C dot A. Same that we did in the previous one. This time it's just in 3 dimensions, in the 3 dimensions. So this will be 2 plus 0 plus negative 2, so this one is going to be 0. BC, 4, minus 5, and then plus 4. So that one's BC. So 4, and this will give us 0, isn't it? So 4, negative 4, so it's also 0. And then AC, 8, negative 10, 2, which is also 0. So all these vectors will eventually be perpendicular. They will be perpendicular. Question 3. Right. So question 3 says, now this is an interesting one, K, negative 1. And here we have K, negative 2, 3. And the question is, for which values of K will these two vectors be perpendicular? Now what do we know? When will they be perpendicular? If A dot B is equal to 0. What is A dot B? II plus JJ plus KK. So II is K squared. JJ will be negative 2K. KK is negative 3 is equal to 0. And this is a trinomial. I will factorize this one. It is the factors of 3. Of the factors of 3 is 3 and 1. Signs differ. The biggest combination, which is this one, is negative, and this one is positive. So if k is equal to -1 or k is equal to 3, then they will be perpendicular. And the whole thing is this: if A dot B is equal to 0, then they will be perpendicular. The next one is number 4. Right, question 4. So now we have the vector -1, 0, 2, and we have to show that this is parallel to 5, 0, -10. Now, we've looked at perpendicular now, but when will they be parallel? When will vectors be parallel? Let's just look at the picture. These vectors are parallel. Even if this one's direction is like this, then they are still parallel. So what we do is we multiply the one with a scalar. Let's say this is the vector 1, 1. If we multiply that vector with scalar 2, then it is 2, 2. So that's why we know that they are parallel. If you multiply it with a scalar, this is what you need to show. If you multiply it with a scalar. Now, if we look here, 0 times 0 is obviously 0. 2 times -5 is -10. -1 times -5 is +5. So we've multiplied this vector with a scalar -5 to make it parallel. That's what we've done there. Right, the next question is question 5. Question 5. So there we have the vector OA, which is 10, 0. And we have the vector OB, which is -6, 8. There's my two vectors there. Now, in the first place, they want you to find BA. So what we've said already is, what is BA? It will be OA minus OB. OA minus OB. So it is this one minus this one. So 10 minus -6 is then 16. And 0 minus 8 is -8. There's my column vector. Then they say, find the position of C, the midpoint of 8B, and they also say, draw the picture. So if we draw a picture here, this one is 10, 0, so that's probably A, and OB is then -6, +8, so this is B. And they say C is the midpoint here. C is the midpoint here. Now, to find, I have to find the position of C, the position vector of C. So eventually, I want to find OC, because that's the position vector from the origin. So you have to find OC. Remember, that is O. So how will I walk to get there? I will take the long road there and there. There I walk. So it is OB plus BC. Do I have BC? No. But I know that C is the midpoint of BA. And here we already got BA. There's BA. So the midpoint will be a half of that one. Okay? So what is OB? OB is the column vector of B. It will be that column vector of B, which is then -6, 8. And then BC, which is a half of this one, will then be 8, -4. And then you can get the column vector of 2, 4. So the sketch will help you here to do that sum. Right, the next one is number 6. Number 6. Now, there we've got a picture looking like this. This is the vector P, and this is OP. This is the vector Q, and this is OQ. And then they say, write in the vectors OR. Now, to get to R, this is where we take the long road. It is a parallelogram, which means this one is also going to be P. So OR, then the long road will now be Q plus P. And then the next one is QP, that they also want, QP. So QP is this one. So again, I'm going to take the long road. I don't know that one, so I have to take the long road. This one is also Q, but I change direction. Can you see? And then I need to change the sign. So this one will be P minus Q. I change this direction, then I change the sign then there. Okay. And, right. That's as far as we're going to go with this exercise. So in the next lesson, we'll look at the check your progress. Morning, grade 12s. We're looking at vectors, and today we're going to look at Cambridge questions on vectors to give you an idea how they ask it in the exam. Let's just first look at our background knowledge. We know that vectors is a column vector, X, Y, Z. We're working now with 3 dimensions. And then we work with base vectors, I, J, and K. The formula that we have is that A dot B is equal to magnitude A, magnitude B, cosine theta. That is your formula. Now, what does it mean? A dot B means II plus JJ plus KK is equal to, magnitude is Pythagoras, so it's then I squared plus J squared plus K squared. Multiply with the second vector, I squared plus J squared plus K squared cosine theta. And what we actually want to find is theta. So eventually, we're also going to say that cosine theta is then A dot B over magnitude, or we can write it like this, magnitude A, magnitude B. That is what we're going to do. What we must also clearly understand is that it is this angle between 2 vectors without going arms. Make sure that you don't change the direction here. So this is AOB, for instance. Then this is vector OA and OB. That is what we will use, arms out. Right, now let's look at the questions. There's the first one. In this question, I, J, and K are unit vectors in the direction OX, OY, OZ, which means they start at O. Now we ask, write down the coordinates of the point C, the coordinates of the point C. Now, the coordinates of the point C will now be, this is where we will find it. It is the coordinates there of C. And I is X, so it will be 3. There is no J, so that is a 0. Don't leave it out. And K is -4. So that is the coordinates that we have there. Right, now number 1b. Now they ask us to find BC. We have to find BC. Look at this. It is OC minus OB. It is always the second one minus the first one that you have there. So now I'm going to take OC, and it's then that 3 minus 4, which gives me negative 1i, and then 0 minus the j, so minus minus j is plus j, and then the negative 4 plus the 3, or actually minus because we are subtracting, so minus 7k. So there is the vector BC. Number C says, find the unit vector of OA. Now, the unit vector means there's 2 steps. You have to get the magnitude of this vector, and then we multiply it with a reciprocal. So to get the magnitude, we work with Pythagoras. So it will then be 1 squared plus negative 2 squared plus negative 2 squared. And that gives me 3. And then step 2, you multiply with a reciprocal. So it's a third of I minus 2j minus 2k, which we can also write, it doesn't matter how you do it now. It is then a third I minus 2/3 j minus 2/3 k. That is then your unit vector, the unit vector. Then at number D, they ask you now to show that the angle is 90 degrees. Now we know if A dot B is equal to 0, then we get that 90 degrees. Why? Because you want to calculate cosine theta is equal to 0 now. So if you press the calculator, second function cosine, then we get that theta is 90 degrees. So you don't need to work with the whole formula. We're just going to work with A dot B. A dot B. And this is then OA dot OB, because that's the angle. We want to find that O is 90 degrees then there. So what is A dot B? It means II plus JJ plus KK. Negative 2, 3. And we can show there now that this is 0. Don't stop there. So 0 is equal to cosine theta. Conclude now that theta is 90 degrees. And then OA will be perpendicular to OB, because that was what you were actually supposed to show. So make the conclusion on that point there. Now, the last question, or the last part of the question, is now number D, where we have to find angle AOC. So it will look like this. This is what I showed you just now. AOC with vectors arms out. So it is the vector OA and the vector OC, which we already have there, with which we can work then. Right, okay, I can take a new page then now here. Okay, so what I'm going to do then is that A dot B is equal to magnitude A, magnitude B, cosine theta. So what does A dot B means? II plus JJ plus KK. So I'm working out with this vector OA, which is I minus 2J minus 2K. And I'm working with OC, which is equal to 3I minus 4K. That is the two vectors. So here, for A dot B, you mix the two. So II is then 1 times 3 plus negative 2. Now look at this one. There is no J there, So you're going to multiply with a 0 here. You multiply with a 0. And then minus 2 times negative 4. That is then the calculation for that one. And then we have the magnitude. Now you just work with this one vector here. So it will be 1 squared plus negative 2 squared plus negative 2 squared. Then we take this vector now here, which will be 3 squared plus negative 4 squared. And then we have cosine theta, the angle that you want to calculate. So cosine theta is then equal, and make sure that you write down all these steps because there's method marks, and if you leave it out and your question is wrong, then you get no marks. So this is 11. The magnitude here is the magnitude of 9, which is 3. That one is the magnitude of 25. And now we can just press the calculator, second function cosine 11 divide by this, and my answer is 42.8 degrees. 42.8 degrees. Right, let's look at question 2. Okay, so here's the next one now. Right, the next one. The vector AB is 2I minus 3J plus 6K, and the point A is now negative 3, 3, 3. So you've got a vector and coordinates, and we have to find the coordinates of the point B. So now it means we move from this point A with a vector to B. So you're going to add them. We can do that because you add x and x, y and y, z and z. So this one is then going to be the coordinate negative 3 plus 2, which is negative 1. Remember, this is now coordinates that I want to give. Then 3 minus 3 is 0. And 6 plus 3 is 9. So there is the coordinates of B. Right, the next one. The vector CD, where P can take different values. Now, this is a very interesting question. We've seen that they've asked it several times from there. What happens if vectors are parallel? They can even go in different directions, and then they are still parallel. But the one is multiplied with a scalar. We need to find a scalar with which you multiply the whole vector. Now, if we look here now and here, from 2 to negative 4, I multiply with negative 2. Negative 3 times negative 2 is 6. So I have to multiply the 6 there with negative 2, which makes P equal to negative 12. P is then negative 12. So that's when they are parallel. Now the next question is when they are perpendicular. What happens if they are perpendicular? So this is now question 2, B2. And they will be perpendicular if what? We said if A dot B is equal to 0. Then they will be perpendicular. So that's how we're going to find that if A dot B is 0. So 2 times negative 4 plus negative 3 times 6, II plus JJ plus KK plus 6P must be equal to 0. Then we can find the value of P. They are perpendicular if A dot B is equal to 0. And the answer is then P is equal to 4 1/3. 4 1/3 there. Right, now question 3, B3. And we have to find the angle now between AB and CD. So we're going to work with these two vectors, AB and CD. But we don't have them. We don't have AB and CD, so we first need to find them. If we go back there to the previous question, looking at the question here, then you can see that we have AB and we have CD, so we can use them. Okay, luckily we can use them this time. Okay, so it is then just A dot B is equal to magnitude A, magnitude B, cosine theta. This time we have them. Sometimes we first need to find them. So this one makes it very easy. What is A dot B? II plus JJ plus KK. Negative 3 times 6 plus 6 times 2 is equal to, now remember, here you mix the two. Here we just want the magnitude of AB. So we're just going to find the magnitude of AB. 2 squared plus negative 3 squared plus 6 squared. Then the magnitude of the next one, which is negative 4 squared plus 6 squared plus negative 2 squared cosine theta. And again, it's very important that you will write down your values every time. So this A dot B I have is negative 14. Don't throw the negative away because that will change theta to a obtuse angle. And this is then 49. I divide to get it away there. The square root of 56 is equal to cosine theta. Second function cosine, and theta is 105.5 degrees. And you can see it's an obtuse angle. You can see the obtuse angle in there. Right. Now we look at question 3. Right, there's question 3. OA is the vector 2i plus j minus k. OC is I minus j plus k, where O is the origin, so from the origin. Find the scalar product, what is that? A dot B, of OA and AC, and hence show that that angle is a right angle there. So this is the number 3A, and we're finding the scalar product. So let's first take OA and OC. OA dot OC. So II plus JJ plus KK. So 2 times 1 plus 1 times negative 1 plus negative 1 times 1. And we should show that this is equal to 0. Don't stop your question there. Make the statement now, theta is 90 degrees. So it is a right angle. Always make the statement that what you're doing in there. Right, now we take B. OABC is a rectangle. Find the coordinates of B. What do we know about a rectangle? We know that our opposite sides are parallel. So it means, let's just draw a little rough sketch, then you can perhaps understand it a little bit better there. So if I have a right angle there, this is O now from the origin, let's say it's OABC, then these two lines will have the same vectors, isn't it? And here they will equal, but they will also have the same vector because they move in the same direction. Now I need to find the coordinates now of B. I need to find the coordinates of B. So that means I have to move either from A with the vector OC to find B, or I can start at C and move with the vector OA to find that coordinate of B. And I can get the coordinates of A and C out of the vectors because there's a relation x, y, z between the two then there. So if I take OA, the coordinates of A is now 2, 1, negative 1. This is the coordinates of A. And the coordinates of C is 1, negative 1, positive 1. There's the coordinates. So now let's say we move this vector. We just start with the coordinates of A. I want to move to B, so I have to move with OC. So I'm going to take the coordinates of A and add then this. So 2 plus 1, we want to find B now. So 2 plus 1 is 3. Negative 1 and positive 1 is 0. Negative 1 and positive 1 is 0. So there is the coordinates then of B. Right. The next question says now you have to find DA and DC. It's just here at the top. Here's the question. Use the scalar product to first find DA and DC, and we have D's coordinates to be 0, 2, 2. 0, 2, 2. So we're going to do the same thing now here. From 0 to 2, I'm going to move then to with A. So actually, perhaps let's get the picture here. Here's the point D, which is 0, 2, 2. Now, DA is OA minus OD. Don't forget that, because if you do that wrong, everything is going to be wrong. So it's the second one minus the first one. We have OA, it was given. There's OA, 2I plus J minus K. So, and then here I have coordinates, but I can also change this to be 2J plus 2K. So I can change from coordinates to base vectors. This is what I'm doing here. So now I'm adding this to OA, and if we add that, or actually subtract the two from each other, I have 2I minus J minus 3K. Here is now I, so it remains that 2I there. And then the second one that you need to find there is now DC. DC, and DC is going to be OC minus OD. So there we have OC, here we have OD, so that will then be 1 minus 0, which is then 1I, and then negative 1 minus 2, which is negative 3J, and then 1 minus 2K, which is minus K. So there is my two vectors now. So we have now, this is DA and this is DC, and that is what we're going to work with now here, because they want you to find angle AD, C, arms out. So we need vector DA and DC, which we luckily have there on that side. Okay.